exactly how he'd got from where he started to the startling ideas with which he ended up.
Yet for Maxwell, the world now fitted together beautifully. If light is an electromagnetic wave, then the different colors of the spectrum correspond to waves vibrating at different frequencies.
There's red at one end. This is light that's vibrating pretty slowly. And then as the speed of vibration increases, we see the colors from red to orange, all the way up to blue and violet. Violet light vibrating extremely fast.
Other mysteries also fell into place, like the apparent presence of light, even when it can't be seen.
Beyond the edges of what we can see, beyond the visible spectrum, there's something very spooky indeed. There's invisible light. There's a radiation we can't see. Faster than blue, faster than violet, there's ultraviolet light.
It was this form of invisible light that was mysteriously fogging photographic paper.
At the other end, vibrating slower than the red, is infrared, heat radiation.
This is the mysterious source of heat that scientists had found associated with light.
The spectrum gets wider and wider.
The very neatness of the whole edifice gave Maxwell enormous satisfaction.
One of the things that Maxwell thought was that there's a really deep relationship between the beauty of mathematics and the reality of his science. If something's true, Maxwell reckoned, you must be able to express it in an aesthetic form. And that's what the equations are doing for him. They summarize this idea that there's a profound relationship between the way the world works and our understanding that the way the world works is beautiful.
In the years to come, these 4 equations would have an enormous impact. They would influence every new technological development forever after.
The relation between light and civilization has always been pretty important, but after Maxwell's equations, nothing was ever going to be the same again. He was going to bring light into dark corners, and his tools and techniques were going to completely change the history of the world.
Society was about to change forever, though not necessarily for the better. Maxwell's equations arrived at a time when Victorian Britain was hungry for new forms of light. Gas was hot, smelly, and occasionally dangerous. Now there was a serious alternative.
Maxwell's equations unlocked the potentiality of electromagnetism. What could now happen was that people could master magnets to generate a constant and reliable electrical supply. And that electrical supply at last made electric lighting viable. It's a really good example of the way in which something that might seem abstract and out of this world is brought down to earth intelligent and inventive men would be able to exploit the potential and make lots of money. One of these men was a chemist working in the north of England.
Newcastle was a boom city of the 19th century. It was full of entrepreneurs and businessmen with an eye on the main chance and the learning and skill to follow any business opportunity. One of them was the local manufacturing chemist, Joseph Swan, a gentleman of letters, but with the keen eye to spot any commercial opportunity that would come his way.
Victorian engineers were already experimenting with primitive ways of using electricity to make light.
Electric light pulled in an enormous number of people's interests. It drew on state-of-the-art engineering. But the problem was that the current form of electric light in use, arc lighting, just wasn't cutting it. It didn't really work. It was unstable, it was noisy, it burst. There had to be a better way of bringing illumination into the home and into the factory.
Swan set about finding a solution.
One alternative to lighting by electric sparks would be to use the fact that some substances glow, they incandesce when you pass electricity through them. The problem with that kind of electric glow is that anything that glows so brightly is likely to burn and disappear. The solution would be to get it to glow in a vacuum where there's no air, so combustion couldn't happen. And this turned out to be crucial for the development of electric light. It was like a really successful convergence of technologies at just the moment when electric generators were reliable enough to produce the electric inputs for these lights. At the same time, big vacuum pumps came on stream that could suck all the air out of bulbs and maintain really, really low air pressure. With this convergence of technologies, it became possible to think of having a light bulb with a glowing filament in a vacuum.